In the silent, unending theater of the cosmos, a stage of unimaginable scale, countless dramas unfold. Stars are born in fiery nurseries, galaxies pirouette in a gravitational ballet, and on one tiny world, a young species has just begun to look up. For all our noise and ambition, we are a civilization defined by a profound cosmic silence. So we listen, and we keep a watchful eye, driven by an insatiable curiosity to know, are we alone? Our sentinels are robotic and tireless. A global network of powerful telescopes scans the heavens night after night, charting the predictable paths of planets and asteroids. Their primary mission is planetary defense, to guard against threats from within our own solar system. But they are also searching for ghosts, celestial travelers not bound to our sun, but merely passing through from the vast, dark and lonely expanse between the stars. And on the night of July 1st, 2025, an automated alert rippled through the system. The Asteroid Terrestrial Impact Last Alert System, ATLAS, had flagged an object unlike any other. At first it was just a handful of pixels moving against the stellar background. But as astronomers around the world urgently plotted its trajectory, a startling picture emerged. The path wasn't an ellipse, the gentle repeating loop of a body tethered to our sun. It was a hyperbola, the unmistakable signature of an interstellar visitor. This celestial wanderer was moving too fast, its trajectory too steep, to have ever been a part of our solar family. It was a tourist, not a resident. This discovery marked only the third time in history humanity had knowingly played host to such a visitor. The first, Oumuamua in 2017, was a bizarre cigar-shaped enigma that accelerated mysteriously. The second, Borisov, was a more familiar-looking comet. Now this third object, designated 3I/Atlas, presented a new mystery, a fresh page in an incredible story. The news erupted. Within hours, a jolt of electricity shot through the global scientific community as telescope time, the most precious commodity in astronomy, was frantically reallocated. But the excitement wasn't confined to academia. The story broke through the noise of daily life, capturing the public imagination. For a moment, a world of billions turned its collective attention upward, united by the arrival of a single, silent traveler from an unknown shore. As the initial data streamed in, the object began to reveal its character. It was large and it was icy, developing a faint gaseous halo, a coma, as the sun's warmth began to sublimate its frozen surface. This pointed towards a natural origin, a classic interstellar comet. Yet, the ghost of Oumuamua and its strange, non-gravitational acceleration lingered in the minds of many. The debate that had surrounded that first visitor was instantly reignited, splitting observers into two distinct camps. On one side, the pragmatists. To them, 3I/Atlas is a natural comet, a priceless time capsule carrying the chemical fingerprints of its birthplace. On the other side are those who dare to ask a more profound question, fueled by the lingering mysteries of our first interstellar guest. Could this be something engineered? A deliberate construction? An alien probe, silently scouting our cosmic backyard? The two possibilities represent the greatest questions of our cosmic search. Is it a message from nature, telling us about the universal processes that create worlds? Or is it a message from someone else, telling us we are not alone? The truth is out there, hurtling toward us at over 100,000 kilometers per hour. And as 3I/Atlas draws nearer, our most powerful instruments on Earth and in space are turning to face it, ready to find the answer. At the heart of the mystery lies its most startling feature, its sheer breathtaking size. 3I/Atlas is a behemoth, vastly larger than its predecessors. Our first interstellar visitor, Oumuamua, was the size of a skyscraper. The second, Borisov, a more conventional comet. But 3I/Atlas is on another scale entirely, with a nucleus estimated at over 50 kilometers in diameter. It is a rogue world, a wandering mountain of ice and rock. This presents a profound puzzle. Our models of planetary formation predict that small objects are common and massive ones are exponentially rare. The gravitational chaos needed to eject an object from its home star makes it far easier to fling away a pebble than a mountain. For the third interstellar visitor we've ever detected to be this massive is wildly improbable. It defies all our models of galactic demographics, an anomaly so extreme it forces us to question everything. Our most powerful instruments revealed more strangeness. The James Webb Space Telescope was tasked with observing it, and astronomers expected to see the familiar spectral fingerprints of water and silicates. Instead, the telescope returned data that only deepened the enigma. It detected peculiar emissions from its glowing coma, signatures that didn't match any known comet in our catalogs. The object was speaking a chemical language we didn't recognize. The most glaring anomaly was its metallic composition. The spectrographs clearly showed nickel vapor, but the iron that should always accompany it was completely absent. In the cosmos, nickel and iron are forged together in dying stars. To find one without the other is like finding a shadow without an object casting it. As scientists debated this impossibility, the object itself began to transform. Its initial reddish hue, typical of surfaces irradiated by long exposure to deep space, faded, replaced by a distinct, eerie green glow that intensified as it neared the sun. It's also fantastically rich in carbon dioxide ice, far more so than water. This suggests it was born in an extremely cold carbon-rich environment, a place very different from our own solar system. One leading hypothesis points to the outer reaches of a system orbiting an ancient red dwarf star. This raises the possibility that 3I/Atlas could be billions of years older than our own sun, a messenger from a long-dead solar system. Beyond its chemistry, it is the journey itself that stretches the bounds of probability. It's blazing through our system at over 150,000 miles per hour on a path that seems almost uncannily precise. There is no chaotic tumble, no unpredictable wobble. Its path is smooth and stable, as if it's navigating rather than just falling. Then came the orbital calculations. First, its trajectory hugs the ecliptic plane, the flat disk where our planets orbit. Interstellar visitors should arrive from all directions. For one to arrive perfectly aligned with this thin plane is a statistical long shot, an event with odds of less than 1 in 500. A remarkable coincidence, but only the first of many, because the trajectory was plotted forward, and what it revealed was astonishing. It wasn't just passing through, it was on a grand tour. The path was set to execute a multi-planet flyby of Venus, Mars, and finally Jupiter. The alignment required for this cosmic billiard shot is breathtakingly precise. The odds of a random visitor pulling off such a tour are conservatively estimated to be less than 1 in 20,000. The combined probability is less than 1 in 10 million. Faced with this trail of impossible clues, the scientific community is fractured. For skeptics, it's a cosmic coincidence, a lesson that the universe is stranger than we imagine and that given enough time, even 1 in 10 million chances will occur. But for others, the word coincidence is no longer sufficient. They see a pattern, a massive object, an impossible chemical signature, a statistically miraculous trajectory. For them, this is not a random rock. It's the hallmark of deliberate, intelligent targeting. 3I/Atlas joins a very exclusive family. By placing it alongside its predecessors, we see echoes of similarity and profound divergences that make each a unique cosmic puzzle. Oumuamua was strange because it was small, inert, and accelerated mysteriously, without any visible outgassing. Borisov was reassuringly familiar, behaving just like a comet from our own backyard. 3I/Atlas is a perplexing hybrid. It looks like a comet, but it's too big, its path is too perfect. And as we would soon learn, its origin story is far too exotic. By backtracking their orbits, astronomers can trace them to different parts of our galaxy, representing different epochs of cosmic history. Oumuamua and Borisov are from the younger thin disk, but 3I/Atlas is the true ancient mariner. Its trajectory points to an origin in the galaxy's ancient thick disk. It's a contemporary of our own solar system. Each visitor is a sample from another star and another time, a form of galactic archaeology, singing its own very strange song. In the face of these anomalies, the vast majority of the astronomical community remains firmly grounded. They invoke a core principle of scientific inquiry, Occam's razor. The simplest explanation is usually the correct one. And for them, the simplest explanation is not aliens but a series of natural if unusual phenomena. They argue that every quirk of this interstellar visitor has a plausible terrestrial explanation, even if it pushes the boundaries of what we've seen before. This isn't a sign of technology, they contend, but an opportunity to expand our understanding of the cosmos. They argue its immense size, while rare, is not without precedent in the vast census of comets from our own Oort cloud. Its unexpected activity, the non-gravitational acceleration, is explained away as classic cometary behavior, vigorous outgassing of volatile materials hidden beneath its surface, acting like unseen thrusters. Its strange chemistry, lacking the expected carbon monoxide, simply points to an exotic birthplace, perhaps a star system very different from our own. And as for its improbable trajectory, That's not a sign of intent, but a profound lesson in statistics. In a galaxy of 400 billion stars, each with its own retinue of comets, 1 in a million cosmic coincidences aren't just possible. They are statistically inevitable. Somewhere, a celestial billiard ball was always going to be knocked in our direction. But standing in stark opposition is a captivating and controversial counter-narrative, championed by a figure who is no stranger to challenging the status quo. Former chair of Harvard's astronomy department, Avi Loeb. Loeb argues that while the mainstream view is safe, it may not be science. He suggests that an over-reliance on familiar explanations can blind us to revolutionary discoveries. For him, this object represents a critical test for how we practice science, forcing us to confront the possibility that we are not alone. Loeb's argument hinges on the concept of cumulative probability. He posits that while any single anomaly could be dismissed as a statistical fluke, the sheer number of them, all happening in one object, strains credulity. Its extreme, elongated shape, its high reflectivity, its peculiar trajectory, and most importantly, its acceleration away from the sun without any visible outgassing or cometary tail. When you multiply the odds of all these anomalies occurring together in a single natural object, he argues, the probability becomes so vanishingly small that an artificial origin becomes the more parsimonious explanation. He offers a specific, testable hypothesis that the object is not a comet at all, but a piece of advanced technology, a solar sail. A light sail is a theoretical spacecraft propelled by the pressure of starlight itself. A sufficiently thin, large, and lightweight sail would be pushed by photons from our sun, accelerating it in precisely the way astronomers observed, all without shedding any gas or dust. This single hypothesis elegantly explains the object's most baffling characteristics. Its cometary appearance could be nothing more than camouflage or perhaps a thin veneer of interstellar dust collected over an eon-long journey. It could be a probe, a buoy, or even discarded debris from a distant civilization. But Loeb's theories have not gone unchallenged. In fact, they've been met with fierce resistance. The majority of the scientific community argues that he is cherry-picking data, focusing only on the facts that fit his narrative while ignoring those that don't. They accuse him of leaping from unexplained to alien, a violation of the rigorous step-by-step process of scientific discovery. At the heart of their skepticism is a concept called Bayesian inference. It states that our assessment of new evidence must be weighed against the prior probability of a claim. Since we have spent decades searching for alien technology with zero confirmed findings, the prior probability of any object being artificial is considered astronomically low. To shift that belief, the new evidence can't just be weird, it must be unambiguous and overwhelming. A few statistical oddities, they argue, are not nearly enough to overcome that initial, deeply rooted skepticism. Before we can claim an object is alien technology, we must first exhaust every single possible new phenomenon, no matter how strange. The scientific maxim holds true. Extraordinary claims require extraordinary evidence. That would mean finding something that has no known natural cause. This could be the detection of radio signals, observing it perform an impossible maneuver that defies the laws of physics, or obtaining an image clear enough to reveal a manufactured surface, none of which have been found. The debate over this silent visitor is therefore more than a simple disagreement. It is a fundamental conflict over the burden of proof, and how humanity should confront the profound possibility that we've finally received a message from the stars. As the formal debate played out, a far wilder conversation erupted online, a digital wildfire of fringe theories, each more sensational than the last. High-profile personalities amplified the speculation, bringing the alien hypothesis to an audience of millions, untethered by the demands of evidence. Users claimed it was emitting math signals, changing course, or was a hostile probe. The frenzy created a bizarre marketplace of ideas where the most fantastic claims gained the most traction. The object also stirred the world of New Age mysticism, where it was seen not as a threat, but as a long-awaited spiritual catalyst. Contactees claimed it was a benevolent ship sent to raise the planet's frequency. Others connected it to ancient myths and prophecies, a sign of impending cataclysm or profound transformation. Scientists saw spectral lines in orbital mechanics. A significant portion of the public looked up and saw a prophecy, a savior, or a sign. As 3I/Atlas prepares to begin its long, silent journey back into the interstellar darkness, it leaves in its wake a universe that feels both larger and more mysterious. Whether natural envoy or artificial sentinel, Its true significance lies in its ability to unite humanity in a shared sense of wonder, forcing us to confront the profound questions: are we alone? What else is out there? The evidence leans natural, but the speculation has enriched the discourse, reminding us that science thrives not only on certainty, but on the courage to ask, what if? It is a beacon of cosmic mystery, beckoning us to keep exploring, to keep questioning, and to remember that in the profound silence between the stars, incredible wonders are always waiting to be found.